Hello everyone, let's graph some logarithms. So the game is, just so you understand, we're going to think of these as being the inverse of exponentials. So when I see a logarithm, I'm going to start with an exponential parent function, just like we did when we were graphing exponentials, and then I'll just flip it. We're going to play the same game that we were doing before, but then I'm just going to add one extra step, basically. So if you say graph a base 2 logarithm, what I'm going to do is start with a base 2 exponential. That's a parent function that we have been using to graph the exponentials. 1/2, 1, 2, 4, 8. Okay? That's our parent function. But if I want to graph a logarithm, what I'm going to do is take the inverse, which means I flip all the inputs and the outputs. So now this is 1/2, 1, 2, 4, 8, and this is going to be my outputs. 1, 2, 3. So if I say graph the base 2 logarithm of x, here's your table. 1/2 is at -1, 1, 0, 2, 1, 4, 2, and 8, 3. There you go. There is an asymptote on the y-axis. And now when I draw it, it's going to look like this. Almost. Let's try that one more time. Pretty good, but whatever. Good. Okay. Best you can. You just want to make sure you don't go through the asymptote. That's kind of bad news because it does not ever cross there. You cannot get 0 by taking exponents. So this is the base 2 log of x. That's the function we were actually asked to graph. You start with the exponential table. You take the inverse. Now we have the log. Once you have the base 2 log of x, you can sort of consider that a parent function for all these base 2 logarithms. So if I have this base 2 log of x table, now I can use that to generate more base 2 logarithm tables. So if you want to do some transformations, no big deal. We can do that. If I want to move this thing, let's see, how would this move? Oh, right 7. So if I go right 7, that'll add 7 to all the x's. So the table that would go with that would be 7.5, 8, 9, 11, 15. And if you just go right, the y's don't change. 1, 2, 3. Now I have the base 2 log of x minus 7. What if I have this guy? This would go left 2 and up 4. All functions have the same behavior. Plus on the inside means go left. Plus on the outside means go up. So left 2, I subtract 2 from all of these. So 1/2 minus 2 is -1.5. 1 minus 2 is -1. 2 minus 2 is 0. 4 minus 2 is 2. 8 minus 2 is 6. And if I go up 4, I'll add 4 to all these. So 3, 4, 5, 6, 7. Now I have the base 2 log of x plus 2 plus 4. All I'm doing is translating this table. So left 2, okay, subtract 2. Up 4, add 4. The same way we were doing it with exponentials. What if I give you some negatives in there? I think both of these are pretty similar. I'm going to just take this guy, okay, and we're going to use the same thing for both of these. So for these problems, I'm just trying to get you to realize that here, if you put the minus sign on the outside after you've evaluated the function, you're changing all the outputs to their opposites. So this will now be +1. There's no -0, but negative, negative, negative. That's going to change the y's. And if you put it on the inside here, that's going to change all of the x's. So just something to think about. Changing the outputs, changing the inputs, the sign of them. Now let's kind of go from scratch. If I say graph a base 3 log of x and then translate it, let's first start with our parent function, 3 to the x. And that's 1/3, 1, 3, 9, 27. That's my parent function. That's what I'm going to start with. Now, I'm going to need 2 more tables. I'm going to flip that, and now I'll have the base 3 log, so 1/3, 1, 3, 9, 27. That is the base 3 log of x, because I took the inverse, I flipped it. Now I need to translate it, so I'm going to go right 1 and down 2. So I'm going to take this guy, and if I move it right 1, I'm going to add 1 to all these x's, so now it's 1.3, and 2, 4, 10, 28, add 1. Subtract 2 from all the y's, because I'm going down 2, so -3, -2, -1, 0, 1. Now I have my actual function, that's this, f of x. Should use different letter there, let's call that like g or something. But okay, now I can graph it. 1.3 is at -3, right? about there. 2's at -2. 4's at -1. 10's at 0. I can't get that on the page. And now, so for this problem, since it went to the right one, the vertical asymptote will go to the right one. For exponentials, we follow the vertical shift for the asymptote. For logs, we follow the horizontal shift, so right one. And now I have this. Well, it's tough to do with this tablet, folks. I'm trying. Yeah, not my best effort, but it's okay. All right. So there's my base 3 log of x minus 1 minus 2. And all I did was start with the parent function, take the inverse, and then translate it. And that's the whole game. If you can create the parent function for whatever the base of the log is, then you can create the logarithm the same way as graphing exponentials. The other thing you might be asked to do is to give me the equation from a graph. So if I give you the graph, I'm going to tell you how it looks. It's going to say y equals the base a log of x. So we have to figure out what the base is because I'm giving you an xy pair. Y is 1/2. I don't know a, but I do know that that's when x is 3. And then I say a to the 1/2 equals 3. Remember, that's the same as saying the square root of a. So that means a is 9. Because if you square both sides, you get 9. So this is the base 9 log of 9 log of x. That looks kind of like an a again, but it's a 9. 9. Why? Do better. All right, that's about as good as it's going to get. Okay. And you look at it, you're like, oh, okay, I get it. 9 to the 1/2 is 3. One more, just like that. Base a log of x. So we know y is 2. We don't know a, but we know x is 9. A squared is 9. Oh, a is 3. So this is the base 3 log of x, which we have that in our table right here. 2, 9. So that's the, where'd it go? There we go. Base 3 log of x. Y equals the base 3 log of x. So if you are given an ordered pair and you're given the structure of the equation, you just plug it in and you solve for the thing you don't know. So that's it for graphing. You have some practice problems. Make sure you get those done and make sure you hit that like and subscribe.